Hi, today we're gonna start solving a Pokemon-themed Pwnable challenge from Plaid CTF 2014. Let's start playing with binary. We have a menu with a series of possible actions like walking into the grass, releasing a Pokemon, changing our Pokemon artwork, and so on. We begin by inspecting our Pokemons. We have a Pidgeot, we can see its name, Bird Jesus, health, attack power, and the attack name. Let's now try to walk into the grass. Let's try again. We found a Kakuna. We can use option 1 to attack it, and it died. Let's keep walking. Another Kakuna appears. This time we try with the Pokeball. And we successfully caught it. Let's give it a random name. And now, if we inspect again our Pokemons, we have also Kakuna. Let's try option 5. We send some random data, but nothing seems to happen. So we need to dig deeper to understand what's going on. So let's start reversing our binary with the Ghidra. We create a new project named Kappa. We load our binary. We can see some basic information. We open it in the code browser and we analyze it with the default configuration. At the bottom right you can see the progress of analysis. You can seek to addresses and labels with the G shortcut. We seek to the entry point. This is the main function. We can rename it with the L shortcut. You can patch a sleep function to speed up the testing phase, but I wanna leave the binary as is. So let's start to analyze this function. This allocates some memory with malloc. Then it copies some data at the beginning of this structure. And we can see that this is the name Bird Jesus we saw before. Then a string is copied into another field of the structure. So this is actually a string. Then this address is copied into this other field. And this is a pointer to this string, which is the attack name. Then we have the health and attack power. And finally a pointer to this function, which is the inspect function for the bird Pokemon. Let's go back to this function. Finally, a pointer to our newly created structure is saved in this variable, and the value 3 is stored in this other variable. Let's begin by creating a structure for the bird Pokemon. As you can see, the automatic creation of a structure identified correctly some fields while others are wrong, but we're gonna fix it in a moment. Let's begin by renaming the correct fields, like the artwork, the attack name pointer, the health, attack power, and the inspect function. Let me rename this variable just B, and let's modify the type. We name it bird, and now we fix the wrong fields. This is a string, the name. Then we have the artwork, again a string. Now we redefine the type of our fields. And now we can see that the name field is correctly identified. So let's rename this function setupBird, and let's go back to main. This function simply prints a banner. This function can't be decompiled for an error of Ghidra, but we can just use the control flow graph to analyze it. It prints a string, which is the main menu, as you can see. Then it calls this function, which simply reads a character from standard input and save it into a local variable. Then it reads another character from a standard input. This is because it needs to consume the new line character that we're gonna send. And then it will decrease by 0x30 our variable. This is to convert the ASCII digit to an index, essentially to a number. So let's rename this function getC to index. And then it will simply return different values depending on our input. Depending on our choice, we have different cases in our switch statement. Let's start by analyzing the inspect function. Let's rename it. This variable is used as a counter inside a loop, which iterates until it is less than 5, and this other variable is not null. Then, depending on the value of this other variable, we have 3 possible paths where we essentially have different offsets where we have a function pointer. This is because different Pokemons gonna have the function pointer to their inspect implementation at different offsets, because the artwork has a different size, and this function is called with the Pokemon structure itself as the only parameter. So let's rename this I. Let's rename this your Pokemon, and let's redefine it as an array of void pointers. Then we rename this your Pokemon's type, and we redefine it as an array of integers. You can see its elements are 4 bytes wide, and then the function will simply return. Let's go back to main. Then we can analyze this function, which calls this other function, which iterates over our Pokemons, printing their name and a number. Then it reads a digit and it returns this index. So we can rename this function choose Pokemon. And we're gonna rename it this I. We cannot set free our first Pokemon. If we provide a valid index, our Pokemon will be free. Then the pointer gonna be set to null and the relative type gonna be set to 0. And then we're gonna have this loop which will simply moves our Pokemons so that the free slots are at the end of the array. So let's rename these release Pokemon and go back to main. Now we can analyze case 1. Which is the heal Pokemons function. We again retrieve an index, which in this case is just the choice yes or no, actually, not an index inside our Pokemon's array. And if we say yes, it will call this function. We can name it heal. And this will simply iterate over our Pokemons until the index is 5 or it finds a null value. And depending on the type of our Pokemon, it will set its health, which will be at a different offset inside the structure, to the correct initial value for that kind of Pokemon, and then simply return. Let's go back to main. Now we move to the last case of our switch statement. This is the function to update the artwork of our Pokemon. It gets an index as usual. Then it gets a pointer to the relative Pokemon. It computes the length of its artwork. Then it will read that amount of bytes into a temporary buffer named local FBC. And this buffer will be later copied into the artwork field of the struct of our Pokemon structure. Finally, a null byte is appended, so we can name this change artwork. Let's move to analyze the last function, which is the walk function. After some putesses and sleeps, it will increment this variable, which is initially 0, so we can name it simply walk count. And if this variable is a multiple of 13, it will call this function with 1 as a parameter. Otherwise, if a wall count is even, it will call this function with the parameter 2. Otherwise, it will simply print you failed to find any Pokemon. So this is the function that is called when we find the wild Pokemon. We can call it appears. Depending on the value of each argument, we have two possible code paths, and you can see that they are very similar to the setUpBird function we saw before. So this is the relative function for the other types of Pokemon that we have in this mini game. So this is the Pokemon type. We can see that here we have Charizard, while here we have Kakuna. So now we're gonna repeat the process to create the new data types. Then we apply our newly created data types to the parameters of the inspect implementation. This is the Charizard implementation of the inspect function. And this is the Cocoon implementation for the inspect function. In both cases, in the end, this function is called with the Pokemon itself, its Pokemon type, its health, attack power, attack name, and name, I guess. So this is the function which handles the fight with the wild Pokemon. First of all, let's rename the arguments and parameters that we just recognized analyzing the function before. We have the wild type, the pointer to the wild Pokemon, its health, attack power, which is actually an integer, and the pointer to the attack name. At the beginning of this function, we have some output, then a pointer to our first Pokemon is retrieved. If our Pokemon is exhausted, we simply free the wild Pokemon and we return. Otherwise, we call this function, which is simply the fight menu, asking what action we wanna do. If we decide to fight, a field of destructor is extracted, and we can see that this is the attack power by how it's used. So first of all, our Pokemon attacks. Then we check if the wild Pokemon health is less than 1. In that case, we just free it and we return. Otherwise, the wild Pokemon will use its attack, and we're gonna update the health of our Pokemon. And again, if we have been defeated, we free the wild Pokemon and we return. If we choose to run away, again we free the wild Pokemon and we return. If we decide to change our Pokemon, we are asked for an index, and that is used to extract the pointer to this Pokemon and update P. Then we can see the code that handles the Pokeball case, and depending on the value of its health, we're gonna catch it or not. If we successfully caught it, we're asked for a name for the new Pokemon. Then we search for a free slot in your Pokemon's array, and we store a pointer to this wild Pokemon into this array, and the wild type into your Pokemon's type, and we return. If there are no free slots, we are asked which Pokemon we wanna set free to make space, and we can't free our first Pokemon. And finally, if we provided a valid index, we're gonna free the pointer to this Pokemon and update it with the value of the new wild Pokemon. Do you see the problem? Here, when we add our Pokemon into the array, we update both your Pokemon's and your Pokemon's type array. Instead, when we replace a Pokemon with the new one, we don't update its type, and if the Pokemon are of different types, this leads to type confusion. Also, before we saw that at the beginning of the code, some offsets are hard-coded and work for the bird type, but if we change our Pokemon during the fight, we're gonna use the offsets for the bird structure for possibly another type of Pokemon, leading again to a type confusion bug. So in the next part, we're gonna see how to exploit this bug and get a shell.